After filtrate is formed in the renal corpuscle, it then travels through the renal tubule and exchanges with this second capillary bed that's kind of like hugging the nephron tubule. Remember, this capillary bed can be a peritubular capillary bed, as pictured here on the left on a cortical nephron, or it can be a vasa recta, which is pictured here on the right on a juxtamedullary nephron. The pictures on the right of this slide, this picture right here, depicts how a nephron really looks, right? It's kind of folded on back of itself in this area where it can contact the tubule before it goes to the collecting duct. For the remainder of this class, we're going to be using a picture on the left. This is not accurate to what nephrons really look like, but this picture on the left is used for teaching about the renal tubule because it stretches the tubule out and it allows us to tell this really nice story from left to right. But note how a nephron, in reality, it kind of swings back on itself through this loop right there, right? Like notice how the nephrons that are in the kidney here fold back on each other. So we're going to stretch out a capillary bed for a better drawing as well. And this allows us to diagram the exchange that happens between a capillary bed and a nephron. But remember that the capillary bed that we kind of diagram out here, that's not what it looks like. The capillary beds are twisting and turning around the nephrons, and that's more accurate. I kind of like using this diagram here on the left because, or this diagram here in the center, because it shows you the arcuate artery, which is the boundary between the cortex and the medulla of the nephron. I also like how it even shows you the cortical radiate vessels right here radiating out into the cortex. If you take your finger and trace the route of the blood capillaries on either nephron here, you will use the afferent arteriole to enter into the glomerulus and then into the peritubular capillary, which goes all over the place, and then connects back here to the cortical radiate vein. It's the same with the juxtamedullary nephron here. This afferent arteriole leads to the glomerulus, which then goes all around this capillary down into the vasa recta and comes back to fuse with the cortical radiate venule. As filtrate flows through the renal tubule, it's constantly exchanging substances with the capillary beds that surround it. As filtrate flows through the tubule, the cell types also change in the wall of the tubule, and therefore the ability of the tubule to exchange certain substances changes as well. I feel confident in saying to you that all of these cells that are pictured here are all simple cuboidal cells, with one exception, of course. These cells right here are squamous cells, and they exist only in that loop thing right there. This squiggly portion over here is known as the proximal convoluted tubule. And that's because it is proximal to the renal corpuscle, and it's also curvy or convoluted. Notice how these simple cuboidal cells of the PCT, they have a lot of villi on them. We've seen villi before in the small intestine. That was an adaptation for an incredibly large surface area over which nutrients could be exchanged in the small intestine. And here, these villi create an incredibly large surface area for the proximal convoluted tubule over which substances can be exchanged. After filtrate flows through the PCT, it enters into this structure here that is called the nephron loop. It used to be called the loop of Henle, but we're moving away from terms like that. There is a descending loop on the side of the PCT, and then there is an ascending loop on this other side here. Notice how both sides of the nephron, they have a thick and a thin segment in the nephron loop. And this is due to the height of the cells. The thick sections are made up of cuboidal cells, and the bottom of the loop is made up of these very porous squamous cells. Remember that the nephron loops of a juxtamedullary nephron dips deep down into those medullary pyramids of the kidney, whereas cortical nephrons were pretty much all of this was pretty much maintained in the cortex of the kidney. As filtrate flows up this ascending arm, it enters into the DCT, or the distal convoluted tubule. Notice how the diameter of the distal, or of the tubule, like the diameter is getting bigger as we get to the DCT. And the cells, these cells here, they also have villi, but they don't have quite as many as the PCT has. The final part of the nephron tubule is called the collecting duct. And this has an even larger diameter because it's not just draining one nephron. It's draining, these arrows should be going the other way. It is draining many nephrons into the collecting duct. The collecting duct dips down into that medullary pyramid, and it goes all the way to the renal papilla, where it weeps urine into those minor calyces. The collecting duct has two populations of cells in it, and they have two very different purposes concerning pH and concerning the influence of hormones on urine composition. Let's try to simply define the three processes that are required to make urine. Let's try to do this before we make it more complicated. Remember that blood is flowing through the kidney, and it's going to encounter two capillary beds. The first capillary bed is in the renal corpuscle, and the second capillary bed is either a peritubular capillary bed or a vasa recta, depending on the type of nephron you have. It's very easy to see the first capillary bed, which is called the glomerulus, and the fact that the glomerulus is fed by an afferent arteriole. And this is the same as it is for any other capillary bed in your body. The efferent arteriole, which carries blood away from the glomerulus, is different because other capillary beds in the body are drained by a venule. But this afferent arteriole transitions into being either a peritubular capillary or a vasa recta, forming the second capillary bed that blood will experience in the kidney. And then this capillary bed twists and turns and hugs the nephron, all the while exchanging with it. When blood enters the glomerulus, it is immediately filtered, separating everything solely by size. Things larger than albumin go into the efferent arteriole, and things smaller than albumin go into that capsular space surrounding the glomerulus, which is drained by the PCT. This is really no different than the filtration that goes on in the arterial side of any capillary bed. Substances are being pushed out of the glomerulus and into the capillary space by filtration. As the filtrate flows in the nephron toward the collecting duct, blood also flows along in this capillary bed. And it's all headed to a cortical radiate venule, which then drains that second capillary bed. And this is the same process that we would expect, that there's reabsorption that moves items from the tubule to the capillary bed. This is no different than reabsorption that we saw on the venule side of other capillary beds, and it's driven by the colloid osmotic pressure of the salty blood in the capillary. However, there is one more process here in the kidney. There is a process that is called secretion, and it moves things from the capillary bed to the renal tubule. We do not have this process of secretion in all of our other capillary beds. I think of secretion as the way to get rid of large things that I don't want. See, in the glomerulus, large substances like toxins are kept in the efferent arteriole. They're kept in the blood because they're too big to filter out. The glomerulus is like, yeah, I know you're toxic, but you're just going to have to stay in the blood. I don't filter you out. But I don't want those toxins in my blood. And the kidney gets a second chance to remove those toxins and move them into the tubule during this process of secretion.